You might have noticed that winter is slowly approaching us, and although there are many things to look forward to in winter, one thing not to look forward to is the cold. No matter how many layers you put on, it's still always cold. But what does this have to do with this video?
Well, thermodynamics is a branch of physics that deals with heat and temperature and their relation to work and energy. A very well-known fact that arises from thermodynamics is the fact that heat travels from hot to cold. This means that whenever you're cold, you're technically just heating up the universe, or whatever is surrounding you.
A fun and easy way to remember the laws of thermodynamics is to think of it in terms of playing a game in Las Vegas.
Let's start with our 0th law of thermodynamics. There is a game. What this means is that if there are 3 players, System A and System B, that are in thermal equilibrium with System C, then they are all in thermal equilibrium with each other. They are all part of the same game, which would be the reaction.
This law might seem very trivial and obvious at first. However, mentioning this law in the beginning helps validate what comes next.
Next is the first law. You can't win. This relates to the most famous statement, which says, energy cannot be created nor destroyed, but instead is transformed from one form into another. Energy is conserved, therefore there is no way to win any more than what you started with.
This can be represented by the equation. This formula says that the internal energy of a closed system is equal to the amount of heat supplied to the system minus the amount of work done by the system onto its surroundings. The second law in Las Vegas terms is, you can't break even. This means that the entropy of a system must always be greater or equal to 0. As a reminder, entropy is the quantity representing the unavailability of a system's thermal energy to convert to work. It is often interpreted as the degree of disorder or randomness in the system.
As energy is transformed, more and more of it is wasted. Hence, there is no way to break even.
And last but not least, our third law of thermodynamics. You can't get out of the game. The third law attempts to define what the limiting behavior of a system is as its temperature reaches absolute 0. It is the hypothetical temperature at which all molecular motion stops.
For all molecular motion to stop, that would mean that each system would stop reacting with each other, hence leaving the game. However, absolute 0 is not possible, and so the game can never end.
There is a simple expression which can be used to calculate the entropy of a system. It states that entropy is equal to the product of the Boltzmann constant and the natural logarithm of the number of equally probable microstates. These are the arrangements of each molecule in the system at an instant.
And there you go. Hopefully that gives you a better understanding of the fundamental laws of thermodynamics and how it can be interpreted.
Don't be too worried if all of this doesn't click from the start. After all, what happens in Vegas stays in Vegas.
Stay tuned for our next video, where we'll actually go into these laws in more detail. Make sure you comment, like, and subscribe for more CHPY Talks.